Okay, in this problem we are given that a block is sent sliding down a frictionless ramp. So this is the frictionless ramp here, and its speeds at point A is 2.2 meter per second, and at point B is 2.6 meter per second. So this information is given, and again it's given that next it is again sent sliding down the ramp, but this time its speed at point A is 4 meter per second. So second scenario, where at point A its speed is 4 meter per second, so we need to find what is its speed at point B. We are not giving anyone, not the inclination angle, not the distance between point A and B, nothing, but that should be okay. So what we know the velocities or speed at each of the points. So we know the corresponding kinetic energies. So at point A, the kinetic energy will be, if I say MA1 maybe, because there are two scenarios. So at first condition, half m being the mass of the object, VA1 square, that is its kinetic energy. And at point B it will be half m VB1 square. So kinetic energy at point B is greater than point A, because what happens is at point A is at a higher height than point B, this much. So when it has moved from point A to B, this potential energy corresponding to this height is converted into kinetic energy. So that much it has less potential energy at point B than it had at point A, and that less amount of potential energy has been converted into kinetic energy. No other energy loss, because the ramp is frictionless. So what happens, we can write like this. If we call this height difference between A and B h, then it will be let's say half mvb square, that bv1 square, that will be equals to half mva1 square plus mgh, because h being the height, difference of height. So what we can do, we don't know the mass, but we don't need to. We can cancel all the m's there, and maybe I will multiply both sides by 2, so it will become VB1 square equals to VA1 1 square plus 2GH. So we can write what is 2GH, that will be VB1 square minus VA1 square, which will be of course 2.6 square minus 2 square. I will leave it like that. So in the second scenario, we don't know what is the velocity at VB2. So at VB2 it will be the same thing, kinetic energy at VB2. Sorry, at point B, we don't know the velocity at point B. Since it's second scenario, we will call it VB2, the velocity or the speed at B. So that will be half m VB2 square. That will be equal to half m VA2 square plus 2m just mgh, mgh. So again m can be cancelled, all the m's, and multiplied by 2, so it becomes VA2 square plus 2GH. So now we know what is 2GH. We don't know the H, but we have found what is 2GH from the previous situation. So VA2 is 4 now, 4 square, and this will be plus 2.6 square minus 2 square. So once I solve it, what I got as result is VB2 is, once I solve that and square rooted it, so it became 4.33 meter per second. Got there like this. What I did is, so let me just walk this through. 16, because 4 square is 16, and then what I did is 2.6 plus 2, 2.6 minus 2. So a square minus b square is equal to a plus b minus a times a minus b. So then it is 4.6 times 0.6, and then after that I just plug that value into the calculator, but it doesn't matter because it's just, you can plug this value into the calculator and you will get it. So that's not the important part. What's the important part is here we just knew the two speeds at 2 points, and with that information we could find the speed at the other point when only one speed was known, and that is using just the energies here.